Bryce and I, the science guy. Bryce and I, the science guy. Bryce and I, the science guy. Science rules. Bryce and I, the science guy.
Inertia is a property of matter.
Bryce and I, the science guy. Bryce and I, the science guy. Science rules.
Hello ladies and gentlemen, boys and girls, Bryce and I here. Today we'll be crushing your hopes and dreams as we explained to you why some of your favorite movies are not possible.
No!
Bryce,
I know
please.
Please, Bryce.
I know what y'all are thinking. Watching Bryce and I explain to you why some movies are not scientifically proven sounds boring, right? Wrong. Today we'll be watching thrilling and exciting scenes from Fast and Furious 6 and 7.
Yay!
As we explain why they are wrong and attempt to correct the scenes to make them scientifically
love you,
possible.
Bryce.
So without further ado, let's get into it.
Yeah, Bryce.
All right, so the first thing we'll be looking at today is this.
Whoa, that's crazy.
Wow!
Bryce, how could this
Science
possibly
rules.
be fake? Oh, this is taking a while. Oh,
This is so realistic. I think.
Bryce, how could you say this is wrong?
What?
What?
All right, guys, so here's how I'm going to debunk this one. So how we're going to do this is, so here's the formula we'll need. We'll need distance equals velocity times time, right? So if we do that calculation with the numbers that we got, we'd say that equals 2 times 5, which would equal 10 miles. But we found this too from the car's velocity being 120 mph, which equals 2 miles per minute. So we plug that in here and we realized that they would have gone 10 miles in that they would have gone 10 miles in the length of this scene. And we also researched that the longest runway is 3.7 miles long. Therefore, there's no way this clip is possible. I'm gonna call in my assistant Portarius.
Hey, Porter and I here. So I'm gonna explain this to you. So basically, the problem with this is the longest runway in the world is 3.7 miles, right? Meaning,
Right.
if the plane was going at the minimum speed of 120 miles per hour, it would reach the end of the runway in 1.5 minutes, give or take. That's not including the fact that the average speed of a plane on the runway is 160 to 150 miles per hour, which with the speed traveled and the fact that the scene was 11 to 12 minutes long, there's no way the plane could have physically been on the runway for that long because there's no runway that is at that long in the world.
Wow! You made that make way more sense than Bryce and I did.
You're welcome.
Thank you, Portarius.
See you later.
All right.
The second scene we'll be looking at is this.
Oh my gosh!
Whoa!
What are they gonna do? They're in a building.
It's
No, no.
It's going.
No way!
No,
They're gonna
no
crash
way.
and die. Oh
Cars don't
Oh!
fly. Cars are not supposed to fly.
Wait, that's awesome.
What?
Bryce and I, this has to be real, right?
Look at. I mean, it looks so cool.
Wait a minute, that's
I'm gonna
crazy.
be crushed if this is fake.
Oh. Whoa!
I know you may love this scene, but I'm about to crush your dreams. This just isn't possible. It's more reasonable than the last one, but it's still not possible. And Cornelius is going to tell you why.
Cornelius and I, tell us. Please, Cornelius, we want to know.
Alright. Well, guys, as you saw in the clip there that just played, you have a skyscraper that's a tall building here, and a skyscraper that is also a tall building here.
I remember that.
Alright? And we know that there's a car in this building, and this is the car, and they're driving it and jumping it through this building into this building.
Whoa.
Alright?
So what you're telling me is that there will be increased speed to make it inside to
Yeah, there's gonna be a car going from here to here in the movie. It's all wrong, maybe. So, we know that the car is leaving from here. By the judging of the freeze frame of the movie, it looks like the car is dropping. We'll be generous, maybe about 3 stories, all right? that equals about 10 meters of a drop. All right.
Now we know the towers where the scene is filmed is in Abu Dhabi, okay? And we know that these towers are roughly 150 feet apart.
No way.
Now, 150 feet, you say? That's a certain amount of meters. It is. So, now,
We don't do precise measurements here on Bryce and I.
only when it matters. And that one,
Does matter just
45.7 meters.
Now we look at the kind of car that they're driving. The car they're driving here is called a Lycan Hyper Sport. All right. So we know because of the specs on this car that the Lycan Hyper Sport can go from 0 to 60 in about 2.9 to 3 seconds. Okay.
Wow.
All right. Now we also know that in 2D motion problems, right? That the X and Y variables act independently of each other, okay? So we know that this is negative 0.98 acceleration because of gravity, and we know because of equations and using the Pythagorean theorem that the car is only in the air for about 1.42 seconds, and we know that the distance it's covering here is about 47 meters, okay? Now, all this being said, the jump is fairly realistic. The car only needs to be going about 70 miles per hour to make the jump. However, we know the specs of the building and the room that this scene was filmed in. And we know that it is no more than 43 meters wide. All right?
It also had marble floors.
It did. The initial velocity the car has to be at, the 70 miles an hour, is equal to 32.18 meters per second. All right, so whenever we plug this into the equation of distance equals velocity times time, right, we know that the car takes at least 3 seconds to get up to this time, which means the distance it takes to get up to that time is at least 46 meters. 46 is greater than that. They do not have enough room to get up to this time, so it's all wrong. Wrong.
No, I want it to be real.
And that's why this scene has been debunked. The third scene we'll be looking at is about the infamous bus jump from Fast and Furious 7. This may seem like it may be real, but I'm going to tell you why it's not.
No! Whoa, he's running all the way up the bus.
No way.
No way.
Oh.
Whoa! No way he jumps all that way to the edge of the cliff. That just seems impossible.
Here's why this would never work. So we know that he's working against gravity to jump up, right? So we need to find. So here's our bus down here.
Mm-hmm.
Here's our cliff.
Mm-hmm.
So he needs to work in the X direction and the Y direction to get up there.
Mm-hmm.
So we know that this is 15 meters, and he needs to go 10 meters in the X direction. He is at approximately 105 degrees, and his acceleration equals negative 9.8 as he's working against gravity. So we use this formula here. So we go delta y equals 1/2 times acceleration, which is negative 9.8, times time, which it takes him 3 seconds in the air.
What? That's
So
a
that
long
would be
time.
3 squared all over sine theta, which is our angle. So sine 105. And it comes out to delta y equals 132.68 mph. This is the miles per hour needed to make this jump while falling downwards from gravity. You have your bus here, your guy here. So unless he can generate 132 miles an hour into that bus and be moving 132 miles per hour upwards, there's no way he would have made it to the top of that cliff.
No, what?
You're ruining our dreams.
No.
All right, folks, that wraps up our video today. Hopefully we didn't crush your dreams too much and you learned a little bit about physics. Hopefully you can go watch some movies now and connect the dots if possible. Thank you very much. Until next time, Bryce and I, out!
Yeah!
I love you, Bryce.
Here's an autograph, Lisa.
Please, my arm. Bryce Nye, the science guy.
Bryce!